Sanibonani abafundi, and today we're starting our very last topic, which is called counting techniques. All right, and you're probably thinking, now to count, 1, 2, 3, 4. Well, there's a little bit more to it than that, but not much. Let's dive straight in. We're on page 89 of our workbook, and we're going to count the number of ways things can happen. So, for example, if I've got 3 hats, ezithathu, a green, a brown, and a white, and I've got 2 jackets. I'm a banshee. I'm a bili. Okay? Blue and green. How many different combinations can I wear if I must wear both? All right. So let's just write them down. Okay? I'm going to write them down kind of hat, then jacket. Okay. So one option would be to wear the green hat with the blue jacket. Another option would be to wear the green hat with the green jacket. Right, those are the only options of wearing the green hat. But then I could wear the brown hat and I could wear it with the blue jacket, or the brown hat with the green jacket. Lastly, I could wear the white hat with the blue jacket, or I could wear the white hat with the green jacket. Those are the only 6 things that can happen. All right. Okay. And we're going to ask you to try and just think about a rule that we can generalize as we move forward. But 3 hats, 2 jackets, 6 options. All right. Now this next one, there are 2 roads going from A to B, and then 3 roads going from B to C. And the question asks, how many different ways can I get from A to C? All right, so one option is to take road 1 and then road 3. But we could take road 1 and then road 4. We could take road 1 and then road 5. Or we could take road 2 and then road 3, road 2 and then road 4, road 2 and then road 5. If we count all of those up, you'll see that there are in fact 6 again. 2 roads and 3 roads, 6. Okay, we're going to ask you to pause the video and just try this question, just the one about 2 shirts, 3 pairs of longs, and 4 hats. How many different outfits can I wear if I wear all 3 items? Okay, so in fact, the final answer is actually going to be 24. All right, and I'm going to call the shirts S1 and S2. I'm going to call the longs L1, L2, L3, and I'm going to call the hats H1 and H2. All right, and I'm not going to write down all 24, but what I am going to do is I'm going to show, we know that with 3 longs and 2 hats, that there will in fact be 6 options. All right, and I'm going to write those down. Just the longs and the hats. Longs 1 with hat 1. Longs 1 with hat 2. Longs 2 with hat 1. Longs 2 with hat 2. Longs 3 with hat 1, and longs 3 with hat 2. Now, that's just the longs and the hats, and we've got 6. And we shouldn't be surprised by 6, because before, when we had 2, so there are 4 different hats, sorry. So I can have long, there's actually a whole lot more here. So I'm going to scrap that, and I'm going to just do the shirts and the longs. All right, because there are only 6 of those. All right, shirt 1, longs 1, shirt 1, longs 2, and shirt 1, longs 3. Now, shirt 1, shirt 2, longs 1, shirt 2, longs 2, and shirt 2, longs 3. Okay, there's 6. All right, now I've got 4 hats. And so for each of these 6 different outfits, I can wear a different hat. So 4 times 6, and that's why it's 24. All right. Okay, and you might notice, you might be starting to say, oh, isn't it just 2 times 3 times 4? And indeed it is, impella. Okay, let's look at this crossword puzzle, all right? So the clue going down says a something can be considered a nuisance. Now, it might be a rat, or it might be a cat, or it might even be a bat. Okay. Then a something, T something N, is considered a good score in a certain sport. I'm going to write this clue number 2. A 10 is a good score in gymnastics, and a ton is a good score in cricket. A ton is another name for 100, if you score 100 runs in cricket. Okay, now, how many total different options have we got? And once again, we're going to multiply the number of choices. We've got 3 choices here, and we've got 2 choices here. There will be a total of 6 different ways we can fill this crossword in. I'm going to say them to you. Rat with 10. Cat with 10. Bat with 10. Rat with ton. Cat with ton. And bat with ton. There are only 6. But we got that answer by multiplying. So, on page 90 now, the fundamental counting principle, and we don't really need to know that name, but what it says is that we multiply numbers of ways. We multiply numbers of ways. Right? If one thing can happen in m ways and another in n ways, then together they can happen in m times n, mn ways. Okay, so let's have a look now. We're going to ask you to pause the video. We're going to ask you just to try this first question. Don't do the second one yet, and then let's have a look at it. Okay, so 3 starters, a choice of 3. So for starters, I've got a choice of 3. For the main meals, I've only got a choice of 2. And for the puddings, I've got a choice of 2. There are a total of 3 times 2 times 2, which is 12 meals. All right. Okay. Then it says, what if I only have 2 courses, but I still eat them in the standard order? In other words, I either have a starter followed by a main, or a main followed by a pudding, or a starter followed by a pudding. There's only 3 different cases, and the one case is to have no starter. So this is where I'm just going to have a main followed by a pudding. The next case is to have no main. I'll have a starter followed by a pudding. And the last case is to have no pudding. So here we would have a starter followed by a main. And let's count how many of these there are. All right. When we have no starter, we've got a choice of 2 mains and 2 puddings. There are 4 possible meals I can have, 2-course meals. If I have no main course, there will be a starter, a choice of 3, and then there are 2 puddings. So that will come to 6. And if I have no pudding, all right, then there will be a choice of 3 starters and a choice of 2 mains. That'll also be 6. And here we get 16. So there's 16 possible sort of 2-course meals, and there are just 3 times 2 times 2, 3-course meals. Okay. All right, so the ability to count things actually helps us in probability. So let's have a look at this. Suppose I toss a die and a coin, and I want to write down the sample space. All right, well, on the die, how many things can happen when I throw a die? That's right, 6. How many things can happen when I throw a coin? 2. The sample space will actually have 12 things in it. I'm going to write it down, even though the question didn't ask us to write down the sample space. I could get heads on the coin and 1 on the die. Heads on the coin, 2 on the die. Heads on the coin, 3 on the die. Heads on the coin, 4 on the die, and so on. Now, you might say we've only got 6 so far, but each of those can also happen with tails. Tails 1, tails with a 2, tails with a 3, tails with a 4, tails with a 5, and tails with a 6. Okay, there's a total of 12 things. Suppose I toss 2 dice. How many different possible outcomes are there? Well, on the first dice, how many things can happen? 6. On the second dice, how many things can happen? 6. There's a total of 36 things that can happen when we toss 2 dice. And I'm not going to write them all down, but I'm going to try and demonstrate why they're 36. We can get a 1 on the one dice and a 1 on the other. We can get a 1 on the first dice and a 2 on the second. Right going across to a 1 on the first and a 6. So I'm hoping you're seeing that there's 6 in that top row. But then we can get a 2 on the first die and a 1. That's different to a 1 and a 2. A 2 and a 2. Right across to 2 and a 6. And this obviously goes right the way down to 6 and a 1. Sorry, 6 and a 1. Right across to 6 and a 6. And I'm hoping you can see why there are 36 things in the sample space, 36 elements in the sample space. 6 rows, 6 things in each row. What's the probability of getting a total of at least 10? So now let's think about how can we get at least 10. We could get 4 and 6, or we could get 6 and 4. We could get 5 and 5, and 5 and 5 only happens in one way. All right, that's a 5 on both dice. We could get 5 with a 6, that would give us 11. We could get 6 with a 5, and that would also give us 11. And lastly, we could get 6 with a 6. I think there's only 6 ways that we can get a total of at least 10. Okay, 10 or more. All right, so the probability of getting at least 10 be 6 out of the total of 36. It actually works out to 1/6. Okay, right. So now suppose I toss a coin 7 times. All right, I want you to just pause the video and try that question. Okay, if we toss a coin 7 times, well, on the first toss, there's a choice of 2 things. On the second toss, there's a choice of 2 things. On the third toss, there's a choice of 2 things. Okay, and this is for 7 tosses. So the total number of things that can happen is actually going to be 2 to the power of 7, which is 128. Okay, now what's the probability of getting tails on at least one of the throws? And you might remember that really big idea that the probability of getting tails on at least one is 1 minus the probability of getting no tails. Now, if we think of all these throws, all the 128 different possible outcomes, there's only one where we get heads on every single one. So in fact, our answer is going to be 1 minus 1 out of 128. It's actually going to be 127 out of 128. Okay, which is very, very likely. Okay, 127 out of 128 is nearly 100%. Let's just have a look. It's not 100%. Okay, 127 out of 128. It's 99.2%. All right. Okay, so I'm just going to write down 2 possible options when we throw a coin 7 times. we could get heads, then heads, then heads, then tails, then heads, then tails, then that's 6, and then maybe another tail. All right, that is one of the 128 different things that can happen. All the things that can happen have at least one head in, apart from heads, 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 heads. 1, 2, 3, 4, 5, 6, 7. All right, that's 7 heads, and that only happens in one way. All the other 127 things have at least one tail in them. Okay, including the one which has got only tails in. Okay, now, 2 ideas coming from sports tournaments. Okay, so in the IPL, there are 8 teams. This might have changed, but each plays one another twice, home and away. How many matches are there altogether? So let's try and think about this. Okay, so suppose they each only play each other once. All right. If we think of the first team, the first team, there are 8 other teams that they have to play. All right. They're not 8 other teams. There are 8 teams altogether. So the first team, if we call the teams A, B, C, D, right through to F, G, H. Okay. Team A has got to play 7 matches. All right. Now, Team B will only have to play 6 matches because they don't have to play Team A. They've already played Team A. Team C will only have to play 5 matches. And so on. All right. Okay. And this goes down to 1. Now, if we add up all the numbers from 1 to 7, we actually get 28. All right. I'm hoping I'm right about that, but I think I'm right. We'll see just now. Okay. Another way of thinking about this is that if we think of each team, how many matches does each of the 8 teams play? Well, each team plays every other team. So, for example, A must play 7 matches. Team H must play 7 matches. So the answer would be 8 times 7. Now, we would need to divide that by 2. And the reason we would need to divide that by 2 is when we count it like this, we're counting when A plays B and when B plays A. So in fact, we need to divide by 2 to get our final answer, and we get 28. Both of these numbers are the same. That's if they only play each other once. Obviously, with home and away, this number will go up to 56. Okay, another idea, and this is in tennis, we have kind of a knockout arrangement where you have 128 players, and so there's 64 matches, all right, in the first round, 32 in the second round, okay, and eventually, so I'll just show you how this works. I'll show you a very small example. Suppose we've got 4 players. Okay, we'll call them A, B, C, and D. Player A plays player B, that's 1 match, okay? And player C plays player D, that's a match. The winner, all right, the winner goes through to the next round. So suppose player A wins and suppose player C wins, all right? Then these 2 play a match, okay? And the winner is the overall winner. Okay, so maybe A wins. Okay, in this particular case, there would only be 3 matches. This match over here, A playing B. This match over here, C playing D. And then finally this match over here, A playing C. All right, so if there are 4 players, there are 3 matches. Okay, now, with 128 players, there's 64 matches in the first round. Then half the players get knocked out, so there's now only 64 players left, and they each play a match, so it's 32 matches. Then 16, then 8, then 4, then 2. Now eventually there's only 2. There's 2 after 2 matches. Then there's just 2 players left, and there's just 1 final. That's the final. That's a semi-final, quarter-final. Okay. If we add all of these up, we get 127. Now, I want you to just think about this, because here's a much easier way of thinking about this idea. Over here, where we had 4 players, we ended up with 3 matches. With 128 players, we ended up with 127 matches. And it's fairly obvious, if we stop and think about it, that 127 is the correct answer, because every time, every match, a player gets knocked out. When we say knocked out, we don't mean knocked out in a boxing match, but we mean that they are out. A player is out of the tournament. Now, if we've got 128 players and we only want 1 player left, we need to have 127 matches. To be able to find our final winner. Okay, so I'm not sure, I hope we followed that. It's probably not an exam question, but it might be, who knows. All right, now we're going to do some exercises and we're going to ask you to try some, but I'm going to just do this first one with you, and then we're going to ask you to try some for homework, okay? How many 3-digit numbers can I make using these digits? 2, 4, 6, 7, and 8, if digits can be repeated. And remember this idea that we multiply number of choices. So that's for our first digit, second digit, third digit. So how many choices have I got for my first digit? 1, 2, 3, 4, 5 things that I can choose for the first digit. Now it says I'm allowed to repeat digits. So if, for example, I used a 2, I can use a 2 again. So I've actually got a choice of 5 again, and I've got a choice of 5 again. There will be a total of 5 cubed, 125 different 3-digit numbers using those numbers. And so, for example, an example of one of them might be 668. All right? Because I'm allowed to repeat a 6. Another example might be 742. Okay, if we wrote them all down, there would be 125. Part B says, what if we cannot repeat them? All right, so now how many choices have I got for my first digit? I've got 5 choices. Now, how many choices have I got for the second digit? I've only got 4. Suppose I use the 6. Then I've only got a choice of 2, 4, 7, or 8. But whatever I use, even if I use the 8, I've only got a choice of 4 for the next digit. And now, by the time I get to the third digit, I've already used 2 digits. 2 of these numbers, and I'm not allowed to repeat them. So I've only got a choice of, that's right, 3. This comes to 60. So if we're not allowed to repeat digits, there's 60 numbers that we can form. If we are allowed to repeat digits, there are 125 digits we can form. We're going to ask you to try questions 2, 3, 4, and 5 before we see you next time. All right, we look forward to that. Have a great day, everyone. Salani Gahle.